everyone. Today, we'll be going into a pre-K classroom. More precisely, we'll be looking at the notion of cardinality. What does that mean? Take this set of cubes, for example. The cardinality of the set is the total number of cubes in the set. So how do we teach this concept to little kids? We often teach kids to place all elements on the table, to align them so as to avoid double counting or skip counting, and then they show us 1, 2, 3, 4, 5, 6. And adults often conclude that they understand there's 6 cubes on the table. Is that how we should do it? Is that what you would have done? Well, I don't hear your answers in the audience, but I'm guessing that there are a lot of yeses. Well, the answer might surprise you, but it's no. Why? Because just as a child may say blue, yellow, purple, white, green, orange, they may think that 1, 2, 3, 4, 5, 6, meaning the number, is just another attribute of each cube, and that this one is just called number 6, and not that 6 represents the total number of cubes on the table. The principle of cardinality states that the last number word said represents the total number of elements in the set. That's why every time a child wants to count how many elements there are in some collection, you have to follow with the question, how many elements are there in all? So that the child associates that last number with the cardinality of the collection. Let's go into a pre-K classroom and see my application of a very well-known study known as the Give Me N task, where N represents any number you say. In this fun and engaging activity, when you ask a child to go get me, say, 5 blocks, you will be able to evaluate if that child understands the meaning of 5 as a quantity. After announcing the lesson's objective, I moved on to the modeling stage of explicit instruction, meaning I explain and model my expectation of the task. What task? Each child will take turns going to fetch N blocks from a pile, place them in the box, then come and form a stack with the N cubes at the center of the room. I demonstrated N equals 1 and N equals 2, and Raphael helped me with N equals 3. The kids quickly realized that the consecutive stacks formed a staircase. Let's watch the kids build stacks 4, 5, 6, and 7. Do you think that's 4? Do you want to check? Go ahead. So what's your decision? If you walk up the staircase, you're going to do 1, 2, 3, and then all the way up to here. Very good. And 5. What do your classmates think? Is it correct? You know you're right because 5 is 1 more than 4. Each time it's 1 more, and 1 more, and 1 more, and 1 more. So you know if you're right or wrong. What are you thinking? As you can see, the staircase formation allows children to self-correct because they see their stack's height is incorrect. Does Matisse have 7 bricks in his stack now? How about a round of applause? You all did a great job. So this lesson taught you that when you count till 7, you know you have 7 bricks in all. From a classroom, we're now going into a living room. And from pre-K students, we're going to go to a kindergarten student. Donatan built his staircase. You're right, 5. Do you think you can place 5 bricks in that box and show Liana? At one point, I asked Liana to build the next stack with 1 brick too many on purpose. Like most children, Donaton was not accustomed to correcting an adult. But in the end, he politely removed 1 brick to make 6.
Bravo!
Liana then verified for Donaton that his staircase was correct by counting each step. This activity requires reflection, attention, keen observation, and self-correction. These are all requirements for critical thinking, analysis, the scientific method. As you saw, when you use big blocks, you can't go so high. If ever you have a kindergarten or first grade child, you may want to use connecting cubes, because then you can build it on a table and continue to 20 if you like. And this mental image of a staircase implicitly teaches what they will learn later, that any number n is 1 more than the previous number n minus 1 and 1 less than the following number n plus 1, expressions that we use in algebra. If you liked this video, please subscribe. See you in the next video.